In this video, I want to show that the invariant holds before we start the while. And so I need to show that Q implies the weakest precondition of the initialization invariant. In order to do this, I need to first instantiate for the initialization and the invariant. I notice that I'm trying to find the weakest precondition of an assignment. So I know I need to perform a textual substitution. In the quantifier, and in fact in the invariant, I'm going to do a substitution of 0 for K. So that leads me to needing to evaluate for all over the range where I is from 0 to 0, including 0, but not including 0, which is empty. And a for all over an empty range I know is true. Then the interval that I find that I have is that 0 is less than or equal to 0 and 0 is less than or equal to n. And I can split it into those two pieces. 0 less than or equal to 0 is true. So it simplifies to 0 is less than or equal to n. In fact, by and simplification, the right-hand side of the implication is going to simplify to 0 is less than n. It's not exactly in the form of and simplification, but I know I can reshuffle using commutativity and associativity. So I find I have Q implies 0 is less than or equal to n, but instantiating for Q, I find I have 0 is less than or equal to n implies 0 is less than or equal to n, which by identity or implication simplification, or you could say weakening, strengthening, whatever you call it, it's true. Which means I know that the invariant holds before I start iterating.